Welcome into the studio. Today I have a very simple project that I wanted to show how easy it is to draw up a simple adapter in Fusion 360 and 3D print it, laser cut it, and or use some sort of manufacturing to cut out a two-dimensional part that will provide you a solution for your car. It can seem intimidating at first if you have never done any kind of drafting or if you've never messed with things like this, but I just wanted to go over the process and show you really how straightforward it is and how easy the Fusion 360 software is to use as well. So to get started, I will introduce this as a crank position sensor for a BMW E30. So it's the M20 engine. This is the factory sensor right here, and it is a VR sensor, variable reluctance. So it has a magnet here with two wires, and as the teeth of the crank position tooth wheel fly past this magnet, it induces a voltage, and the voltage goes out to the ECU and tells the ECU where the motor position is. So it can properly fire the ignition coils and spray fuel at the right time. And although this is a simple solution, I have had a lot of issues with variable reluctance type sensors. They are reliable, but you have to have a very good filtering system to keep noise out. They produce a lot of voltage, especially at high RPMs with a lot of teeth, and they are less reliable in my experience than a Hall sensor. So we will introduce this Hall sensor from DIY Auto Tune, aka the people at Megasquirt. This is on their website. It's a 3-wire sensor and it costs about $40. It's extremely reliable. I've been using them on a few different cars now for about 5 or 6 years and never had a single issue. The difference really between these two is that this produces a digital signal, a 1 or a 0, a high or a low, and this produces a sine wave that increases in amplitude as you increase in RPM, and you have to do a lot of filtering with this, and it's just not as clean as a 1 or a 0 for the computer. The computer really likes to just see on or off signals, and so you have a power, a sensor ground, and an output, and the output just gives a 1 or a 0, and these do not need any additional pull-up resistors. They have one built inside of them. You can literally wire this up and have a perfect crank signal in my experience. So that's the reason we're using it. This is the reason we're getting away from it. And here is the bracketry that we need to adapt this new style sensor to. So the good thing about this is, luckily, in diameter, these are very similar. However, what differs is the length. So when you set them next to each other, one of them is significantly shorter. But that is actually to our benefit, because in this case, it would be hard if the factory one was longer and we had a shorter one, because we'd have to somehow remove material from here to get it closer to the crank tooth wheel. Whereas being longer, we can just add a spacer here and space it out a little bit. So let me show you a previous design that I have used on an M30 engine that we are going to model after today. So this is a basic acrylic cutout that was cut out on a laser, and all it does is takes the bolt patterns from the two different sensors. So this is the factory bolt pattern right here, as you can see, and allows the factory bolt pattern to be adapted to right here on this sensor. And if we just put the factory bolt in it, you can see on this bracket that it fits quite nicely. And the offset here is just the same as factory. So what we can do now is use this little adapter to take the new style sensor, slip it through, and then we just put a fastener here, and we have an adapter that works to give us the correct spacing here and gives this a nice place to mount that's just offset from center. So really, this is probably one of the most simple solutions that you could come up with, I think, for adapting a crank position. You could redesign this entire apparatus, this bracketry, and if you had a mill, or you could 3D print it or something like that. But really, this is a solid, well-known working piece of aluminum, and all we need to do is make an adapter that also acts as a spacer. So in this case, we actually need to add some thickness to this spacer, because my previous design was meant for a bracket that actually had adjustment in it, and you would put a feeler gauge between the teeth and the sensor and lock the hardware. However, on this design, this is fixed, and it just relies on the crank's this crank position sensor to have an air gap that is just set, and you use the same sensor every time. So when you replace it, it's the same dimensions. You don't adjust anything, you just swap the sensor and it's good to go. However, in this case, we just have a little bit more length on this aftermarket adapter for the Hall sensor, or the aftermarket sensor, and we need to account for that. So the very first thing we're going to do is we're just going to take a measurement. So we'll take my calipers here and just set them right here at the top, go down to right here, make sure we're as close as we can get, and then take a look. So 23.85, I've measured a couple times before, and we're actually pretty much closer to 23.75. So we're actually going to use this measurement. After I measured it a few times, I found that that's more likely the best dimension from my 3 measurements that I've taken. So the next one we're going to take a look at is this. As you can see, there is a big gap right there that we need to fill. So we need to come down here, take that measurement, and you can see it's 31.89. So almost 32 millimeters. So there is a difference that we need to make up. So we're going to take the difference between these two and account for that in the software when we go ahead and build that. The dimensions for this backing plate are actually given to us in the DIY Auto Tune website. We can go find this whole dimension, this dimension, and the length and everything here. So this is actually already given to us. Really, the biggest difference that we need right now is the dimensions of this hole and this shape right here. So we're going to jump over to Fusion 360 and we'll cut into what it looks like when we're making this in software. All right, welcome. This is Fusion 360. You can get this for free if you just sign up, give a little bit of information, and you can typically get this for a year at a time education license or a hobbyist license. I think you can get up to 3 years too. But this is what it looks like. This is your drawing area, and we're just going to get stuck into it. So what I like to do is I just named this crank angle sensor 3. I have a couple different ones, so for me I just named it up here at the top as 3. And we need to pick a surface. So it's 3 dimensions. We need to decide what plane we're going to draw in. And I, for this 2-dimensional stuff, always like to just start from a top view. So you just click top over here on the right, and it drops you on the center of these axes right here. So we're just going to go to create a sketch over here on the right, and we're going to choose this plane. So you just click it, and now we're drawing on the top plane right here. First thing we need to do is I have the dimensional reference from DIY Auto Tune. This is the sensor that I purchased. I've just zoomed in like crazy, but you can see right there, this is what we're looking at. They give us nice dimensions right here. So we're just going to start by going off of these, and we'll go from there. So we're going to use the center of the part is going to be this hole where the center of the sensor is, where this tube portion comes out and senses against the toothed wheel. So first of all, we're going to look at this dimension right here. So this hole right here, the dimension is actually 17.86. And since we're not trying to make a perfect fit, we need a little bit bigger than this so that this sensor can slide through the part. Especially, I'll be 3D printing this. There's a little bit of give or take with 3D printing. Sometimes you have, a few tenths or hundredths of a millimeter off, just depending on what we're going to do. I'm actually going to go with 18 on this. I've already cut one at 18 and it works really well. So we'll try 18 and it might measure up to like 17.96 or something like that, but it will be very close. This isn't an extreme precision part, so it won't make a huge difference in the end when we do that. So our first hole will be 18 millimeters, and then we are going to work in millimeters on this. So we're going to take this, we're going to pull it out, and you're just going to type 18 and hit enter. Okay. So the diameter of this is 18 millimeters. That's our first hole. So we'll go back, just make sure, yep, that's right. And then what's cool is if you've never drawn anything like this before, it might be intimidating to think, oh, how do you get this angle and everything? Well, they're just circles within circles. So you have this circle, and then you have another diameter of circle, and then you just connect them with a line. So this right here is actually just another circle, imaginary, and then they're just connected. So we're going to take 23 millimeters, go back here, click here, and then just type 23, hit enter. Okay, we're making our way along. And then now that we have this portion, we are going to work on this next hole. Let's go back and do that. So we got 6.6 millimeters and 15 millimeters. So what I want to do is I'm actually going to click these, and I'm going to hit shift and select both of them, right click them, and then I am going to fix them. So they are going to be locked in this position. They cannot move. And the reason I'm doing that is because these next holes, I want to just roughly place out here and do 6.6, hit enter, and then I will choose this sketch dimension tool and go off of the center of this hole up to the center of this hole. And when I type in here, let's go back over to this, it looks like 22. When I type 22, it will move this small one instead of the big one, the big circle. So you see that right there, it moved this small hole up. This is fixed and cannot be moved, and it will adjust along this axis to give me 22 millimeters between the two center on center, if that makes sense. That's something that if you didn't do that, it would push sometimes whatever the first one you selected would be your base. So if you selected this one first, it would push these big ones out of the way. But nonetheless, we can now that this is centered, we can go off of this and do the next one. And so let me just tab over, and 15 millimeters. So let's type 15 and just hit enter. So cool, we actually have the first two pieces of this right here, these first two circle bases. This is for the new style sensor. And what we're gonna do next, I'm not sure if this is the best way to do this, but it's a way that I have found that works really well. To connect these two, there's almost an infinite number of dots where you could click here, and like you could do this and it would just make a connection, but it's not from edge to edge. And you could do whatever design you want, but I want them to be edge to edge, just like in that dimensional reference here. I want it to be here to here at the top of those circles. So what I'll do is I'll actually hit Control Z to get rid of that, and I will just make a line next to it right here. Okay, and this is also comes in to where we need to fix these. Now that we know that these are where we want them, I'll click this and I'll hit shift and click this, right click and go to fix. And now that they're fixed, we can move this line to touch both of these, and we use what we call a tangent. So this tangent feature, I can click this, and I can click this right here, click tangent, and then click this, and it makes them connect. So if I zoom in there, they're actually connected right here. And then let's get right here and see how close we are. I can just click this, and then they touch. So now I have actually, let me center these. I've actually got these touching right here, and then I can just hit trim and trim off the edge right here that isn't touching, and we have created a line here between those two. Cool. So the next portion that we can do is the old bolt pattern that's going to stick out here. So let's go back to our circles. I'm just going to come over here, and now that these are fixed, I don't really have to worry about anything moving around. The only thing that isn't fixed is this line, but we won't be messing with that line. So we're going to go back into our sketch, and the hole diameter is essentially the same. I measured it at 6.5 millimeters, and this is 6.6. Just to keep things the same, I am going to go with 6.6. It's not very precision because it's just a piece of hardware that has to go through it, a fastener, and it can be a touch loose. It can have a little bit of play on this particular thing. There are things that you really want to be precision with, but this is not one of them that really matters much. I've made a couple of these before, and they work just fine. So let's now go back to my sketch dimension, and I have measured this gap to be 19 millimeters. So I'm going to click and type 19, and you can see it moved it to 19 millimeters. Okay, and that's our hole. The next one, I will actually go and do basically the same thing as this right here. We're just going to go in and measure this distance, and what you can do is you can actually go like, I'll show you. Let me go Control Z. Oh, hold on. 19. Okay, we're just going to draw the sketch dimension right here and type 19. So another way that you can do this is you can measure the inside ring to the outside ring with your calipers and just do a function called shell, which I'll show you here in a second. You just go here to offset, and I can go click, and I can make a positive offset. And I actually went through real quick and I measured the offset to be 2.75. So I'll just do 2.75 right here, and it gives me an offset. It takes this and goes out 2.75 millimeters. So that's another way to do this. If you don't want to measure the outside to outside, you can just measure the inside to the outside of whatever ring that you have going on right there. So one more thing, we'll just go over to add this right here, this line. Oh, let's go Control Z real quick. I'm just gonna get rid of this guy that I accidentally double clicked. I'm just gonna go Control Z here, that, and I'm gonna make another one over here. Just roughly, it can just be over here somewhere. It's gonna happen sooner or later. We'll just make it work and hit shift, right click, fix these in place. Then we'll use our tangent tool again, click on this and this and this and this, and make that line touch the edges of those circles. And then we're going to click this and the circle here, and this circle here. And we're going to go trim. We'll just trim off the edges here that we don't want, that are sticking out past the circles. And voila, look at that. I think we have a pretty good adapter here, very similar to the one I was just showing you earlier. And what we can do now is we can save this sketch. So what I want to do is I'm going to finish this sketch and then we're going to extrude it to make it three-dimensional. So right here, just if we've we've gone through, make sure this is 6.6, 6.6, 2.75 millimeters shelled out, 18 millimeters in diameter here. This dimension is 19. Just double check everything, 22 to this, and just go ahead and hit finish sketch. Now that we're here, the sketch is completed, we can go ahead and extrude. It's up here, and what we're going to do is we're going to select this surface to extrude. We want to extrude everything but the holes right there. And I'm going to turn this by hitting Control, and I'm just going to center this right here. And what I have determined is we had 23.75 was the old length of the sensor, and the new length of the sensor is 31.75. So if we subtract those two, that gives us 8 millimeters. The old sensor adapter I have was 5 millimeters and would not suit this. So since we're making a brand new one, we can just make it the correct length for this style of bracket for the E30. So we'll just go ahead and hit 8, hit enter, and now we have a three-dimensional part. Isn't that cool? So if you didn't catch that, the reason we only extrude the things around the holes is because we just want those to be holes. We don't want to fill them in with material. And we can go ahead now and save this. So you can just hit save, and I'll just make it, I'll call it the crank angle sensor final, and hit OK. And we're just going to go ahead and export it, get it ready to 3D print. So you go to export, and I'm actually going to do a, we could do an STL to print. There's a few different file types that you can 3D print from, and we'll go ahead and just choose STL and export, and it will bring it down from the cloud. And after you've brought it down from the cloud, it'll be here locally on your machine. You can throw it on a thumb drive, and from there we can 3D print this and get it tested on the car. I would also say one thing that you want to note is that this will not be perfect, especially if you 3D print it. And if you do want to get this machined, I would definitely suggest 3D printing it and giving it a few test fits. None of this additive manufacturing stuff is at a hobbyist level, I would say, is extremely precision. So just be careful to check everything and make sure it's exactly what you want before you sent this out to be machined, if that's what you were going to do. So we've got it complete. I can find it in my file explorer now, and we're going to go back to 3D printing this and give it a test on the car. I'll also be giving a link to this in Thingiverse and giving it away for free. So any of you that actually need this part, I am happy to give it away, and you can go ahead and 3D print it yourself. One other note about 3D printing this is it is on the front of the engine, and it will get a little bit hot, but in my experience, I've been using acrylic in the past. It was just a scrap of stuff that I had laying around that I could I could laser cut, and it has held up really well. This doesn't get that hot. It is up front on the motor. It's not near the exhaust. It hasn't really had any issues, so I believe printing this in ABS or some nylon, I would prefer to do it in like a carbon fiber nylon to get the best result, but I don't think anything under 200 degrees will hurt this particular part in my experience. So thanks for watching. I really appreciate you guys following along. Hopefully this helps some of you. It's really cool to work in Fusion and 3D modeling software, so I encourage you to give it a shot. It does take a little bit of time, but very fun nonetheless. Thanks again. By the magic of 3D printing and editing, I present to you the finished final product. I printed a couple of them, and they are looking really nice. The only inconvenience is that due to inconsistencies with different 3D printers and all sorts of different things, when I measure these out, they are not 18. They are 18 or 17 and about 17 and 3/4 millimeter, half in some areas. So the sensor actually wouldn't fit in these when I got them. Everything else checks out. The holes are looking good. They're supposed to be 6.5, but anywhere honestly between like 5.5 and 6.5 would work. So they're working okay for now. That's just one issue with 3D printing that you just can't get around unless you have extremely nice 3D printers and high precision stuff, is that sometimes the dimensions aren't perfect. It's not like you're CNCing these. If I was to have these made out of a solid block of Delrin CNC'd, I think that would be ideal. But for now, we're just going to show how good it actually fits together. Honestly, the dimensions on the outside were pretty much spot on. So I had to go in here and sand this just a little bit, but when I recreate these to use on the car, I'm going to make them out of ABS. This is PLA, so I will not use this actually on the car. This is just for a demonstration of what we can do, and then I'll use the proper material that will hold up to heat a little bit better. I do not trust PLA in my experience. I've had a lot of PLA stuff warp because of heat. So definitely just use ABS or better, something more heat resistant. So anyway, it does fit now that I've sanded it. It's still a snug fit, but it does fit. And if we line it up, you can see. And let me line it up a little bit better. Honestly, the dimensions are really good. You can see kind of there along the side. It lines up really nicely. And all we need to do is put some hardware in it. This is just a 1/4 bolt that I had available. If I were just to go get specific hardware, I'd probably try to get something a little bit lighter. This is sitting out on the edge of this bracket, so if you could reduce the mass so it doesn't vibrate around and cause a lot of ruckus, if it is really heavy sitting out on the end. So I would suggest really locking this down. I also have a nylock, the nylon inserted bolt that I would replace this with. So this is just simple, so I can spin it off with my fingers while I'm using the camera, but I would use a nylock instead of this if I were clamping it down permanently. But yeah, something like this with a washer would be great. And then you can see here, really that just fits dead on. And this pattern right here fits just perfect. And this fits nice and snug up against here, just like it should. And one critique, which anytime you build something like this, you can always critique it and make it better. I did notice that the factory hardware is too short to really give any threads into this piece. It does work for about 2 threads, something like that, but definitely not enough that I would trust holding it on there. What we could do if we wanted to go back and edit this print, this drawing, is bring this down a fair ways and then slope it back up so that it connects to the rest of the piece. But right here where it mounts, we could make it shallower so that this would fit in there just nicely, and we could use the factory hardware. But this factory hardware is also kind of stripped out on the inside, so I would prefer to put new hardware in it anyway. There's something like this Allen that you could use. This is an M6x1, but just for simplicity, so I can show you without an Allen key that I don't have with me right away, we'll just use this and just thread it in by hand real quick. And one thing that you can do as well with this is if you were going to put a lock washer or some blue thread lock, I'm not sure how necessary it is, but you do not want this coming loose. And this is like the one sensor that you absolutely do not want coming loose. So I would use a lock washer or some blue thread lock on this fitting, probably just blue Loctite on this fitting to make sure that it doesn't come loose. But just make sure there's a tiny bit of play in here. So just make sure that the sensor is pushed all the way against the bracket and then tighten it down. But there you have it. There's your adapter. It just moves this 90 degrees off to the side, gives it plenty of space to chill out. It'll be away from stuff. You can flip it if it works better on this side, but this is just hanging off the side of the motor just like this. So here we have it mounted up to the engine, and you can see the tooth gap is very nice. Everything's mounted up and working. I have measured it and it was about 0.66 millimeters of an air gap between the tooth and the wheel. And for this particular sensor, they specify a 0.5 millimeter to 1.5 millimeters. So this is actually perfect, and we would expect to see a very reliable sensor reading from having a nice close proximity to that wheel. So everything fits just fine. You can see right here, obviously I need to get a little bit different hardware. This is just easy hardware to work with, just to test it real quick and make sure it's tight. But yeah, this guy would just go up in the front of the motor, get covered up, and have a good plug-in to put on it, and that would be it. So this looks like a success. I have made one of these previously with acrylic and it worked just as well. So I'm looking forward to see with ABS plastic what it ends up being. So this just shows you from concept to completion, how it looks and how it fits. And it looks like it is spot on. So that's what this is all about. Making useful pieces for your car with just basic knowledge and a little bit of time learning Fusion 360. But it's really simple. Something as simple as this, it looks, almost like nothing, very simple piece, but it can make a really good solution for you if you're trying to do something like adapt a sensor. And you can see when we put these next to each other, they're almost dead on exact correct length. So this 8 millimeters actually did turn out to be almost dead on 8 millimeters when we 3D printed it. So I hope this helps any of you that are interested in getting into 3D modeling. There's little things that seem insignificant and difficult to make, but once you get the hang of it, a little guy like this could really change your project and give you quite a bit of leeway in what kind of sensors you run. I mean, you could run all kinds of different smaller sensors and just change this hole size. There's threaded motorsport style sensors that you could put in here. Really anything that is a Hall effect or VR sensor that you wanted to run, you could pretty much adapt it to fit this. It's very straightforward like you've seen, and only requires a little bit of basic hardware. So if you're interested, give it a try. I'm going to throw this up on Thingiverse. I'll put the link in the description for it. So if you want this, you can actually just go ahead and 3D print it and use it yourself. Thanks again for watching. If you like what we do here, consider joining and liking, sharing, subscribing. It's super cheesy, but honestly, that's how YouTube works. And I want to continue doing this for you guys. So thanks again.